Hello again and welcome. This is the final of the video series. This will be talking about the fifth generative music experiment. This one is called Hold and Division, mostly because that's what this particular generative music experiment is doing in the compulsion sequencer and arpeggio. I think this particular this particular experiment was the most fun to make. It's also the one which in some ways is the most experimental. This one really relies on the generative music process the most. It has nothing in the way of melody. Everything is done through probabilities. When I push play on this one, I don't know what notes will be there. This thing is essentially endless. You could just play this forever and it will be forever changing in subtle ways. So to start explaining basically what's happening here, as you can see here, I've chosen F major pentatonic as the scale, and then you can see here the notes that have populated themselves just here of the F major pentatonic scale, and then you can see here that I actually have every single gate selected. So at any given time, any of these 16 notes will be triggered. And so you can see here in the loop that the loop is always the same for each one. You can see here also that the mode for each one is the exact same. So this is sequencer 1, the hold is for this one, and it's the exact same for every single one. The repeat is also the same for every single one. And then the probability, as you can see, is very slightly different, but they're almost all the exact same as well. And that's what goes for every single one. And so what this means is that the probability of any one particular note being hit is very, very low, but because there's so many possibilities of different notes being hit, it's always likely that one of the notes at any given time is going to be hit. The only thing which changes is that these gates are all running at different rates to each other. So this is all done through the division here. You can see that I've just come up with this division. So this means that, for example, this one will be running the fastest, whereas this one will be running the slowest. It would be the exact opposite if it was on the multiplier, but as you can see, all of the multipliers are all just the way that they should be. So even though this is actually running at a consistent rate of 1/16, because of these divisions, it just means that a lot of these are going to be running extremely slowly, and then some of them are just going to be running only a little bit sluggishly compared to this. Okay, so this one doesn't actually link various devices together. It's essentially just, this is the pattern. So this is the one which is for the signs in space synth, which you can see down here. And then I just have the exact same thing for this chimes synth. I have the exact same thing down here. There's some minor modifications that I've made just as I've been listening to it. Thought, oh, I actually don't really like the low note, or I don't really like the highest note, so I'll make some slight changes as I'm listening to it. And then that's the same thing for this choir, which I've cut out half of the possibilities of the notes, and then just I think two more, which is this this lyre sound, and then finally there's this other sort of pad type sound down the bottom. So they're all playing the same sort of thing. They all have a possibility of hitting, or almost all have a possibility of hitting 16 simultaneous notes, and they're all running from the same probability and whatnot. Okay, so moving over to the right hand side, actually first of all we'll have a look at the we'll have a look at this mixer here. You can see that the mixer, which is down here, you'll notice that by itself it's actually very subtly moving up and down. It's a little bit hard to tell, but it is actually moving up and down. So these are the different sounds that we've got here. As you can see, I've the output, all of the output has all been routed to this. You can see if you flip the rack around, it's very complex with its wiring, this one. You can see it's gone through direct routing, which breaks the internal mixer routing. Everything is being sent directly to here. And so what's actually happening here is I have these chaotic signal generators. I have the 4 outputs of those. They're all being sent they're actually all initially being sent to this scope, this is actually showing what each of these are doing. So this is just a visual representation of what's happening here with these little lights. Okay, so what's actually happening though is it's being sent to here, but then it's also being sent up, up, up. You can follow along these 4 lines here, the 4 skinny lines. That's being sent up, up, up to the 1, 2, 3, and 4 on the back of this combinator device, which has the mixer and a whole bunch of other things in it. And then you can see here that CV in 1, 2, 3, and 4 is changing the channels 1, 2, 3, 4, 5, and 6. And they're changing them these amount. So therefore, basically channel 1 goes to a minimum of 30 and a maximum of 100. Some of them have narrower levels that they go to than that, and things like that. And some of them even have a little bit more, like this one here, which goes all the way up to 115. I think that was the lyre, which I quite liked, that coming into the mix a little louder than the others occasionally. Okay, so basically what I did is I just kind of tweaked the speed of these so they're all subtly different to each other, and then I just tweaked the amount that these are going up and down until I got it to a nice level. I just tweaked their speed and did some other things like that, and then I just sort of let the thing go and see what happens. So that's what I'll do now. I'll just have a quick listen and we can see what it sounds like. So this is the first sound. This is the signs in space sound. So you can see that a number of the sounds are being triggered. After this, there'll be a big gap in noise while they all start to slowly move and then re-loop again. So there's always a bit of a gap in the beginning, and then, but this is only it's only for the first time on the run through, because they're all running at different rates. It just ends up meaning that in subsequent runs through, there's always something being hit at any given time. Okay, so that's what that science in space sounds like. Okay, so moving on to the next one, which is this chimes. It's got a brighter overall sound. You can see here that I've actually moved it so that this one starts in F3, but this one starts in D5, so it has quite a bright sound overall. Okay, then the next one we have is this dreaming wave sound. Now this dreaming wave sound is actually a really interesting one. If we open up the device a little bit, you can see here that it's a little loud, this one, deliberately. But you can see here that I've actually have a number of arpeggios running simultaneous. So what that means is that if you have more than one sound coming out of this, they actually begin to arpeggiate with each other as well. So for example, if this C3 and this F3 are hit at the same time, they'll kind of slowly arpeggiate with one another. Okay, so the next sound is being created by this this choir sound. This one's not in it all that much, to be honest. Oops, sorry, this one up here. This one's much rarer that it will ever trigger, and it's a pretty subtle effect, to be honest. Okay, the next one is this lyre now noise. The thing I liked about this lyre one, you might be able to hear it just a little bit. It has a kind of it has a slight sort of string buzz noise that I really like. And then finally we have this synth sort of pad type sound here. I feel like this one is a bit of a sort of a glue that holds everything together. So that's basically what happens, what's happening. So you can hear that all of the different sounds are all triggering at different times, and you can see here that the volumes are also being completely, they're being changed over time through this chaotic signal generator, which I can't predict. Okay, so moving on, the last thing I wanted to talk about was this visualizer. So for this one, all of the visualizers, there's no visualizer for the overall audio. There's just visualizers for each one of the different sounds. So we've got 6 sounds in total, and so we have 1, 2, 3, 4, 5, 6. So they're just representing the different sounds. I thought that was nice. That was a nice way to do it. So this one kind of flares up occasionally. It's a little bit loud. I quite like that. It does that occasionally. Yeah, so I quite like it that this one just becomes this interesting thing where you can sort of like, oh, which one's going to go next and where. This one took quite a lot to connect up, as you can see from all of this wiring. Okay, well that's all 5 of them. I hope that you enjoyed watching these. Thank you very much for listening.